You're listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson from Protein Machining. And this week, I am rejoined by the Sultan of Small, the Master of Micro, Dan Rudolph. Welcome back.
Hey, Dylan, thank you for having me back. Did you write that ahead of time?
I did, because I didn't want to screw it up. But welcome back. Yeah, it's been, let's see, I wrote what episodes you were on. If anybody wants to know Dan's backstory, go to episode 8. You were our first guest on the podcast ever. And then we had you back on 54. So go back, listen to both of those if you haven't, and you can hear more of Dan's backstory. But I kind of wanted to have you back on because you've had a whole lot of, not turnover, but just everything moving and growing and all that stuff recently. And so I wanted to have you back on and kind of check in and find out all the cool stuff.
Yeah, it has been crazy the last, really since we spoke last. We had a project that we've been working on for about 2 years that's kind of getting into the production mode, and that's precipitated a lot of us having to move everything around and get new equipment in. And it's funny, I was looking back on a YouTube shop tour I made with my son April 2020, and we were watching it, and it was like, oh man, we changed that, got rid of that, added that. And like nothing's the same, but it's kind of crazy how quickly you can change things, and even though day to day you don't really notice it happening.
So I guess what's the new machinery rundown? How many lathes have you packed into that shop now?
Yeah, so we kind of have 2 spaces now that are kind of distinct. We have kind of the shop that we started out in, that's like a 30 by 30 building, and I have 3 RO4s, and then I have a Robodrill, a Haas Super Mini Mill, and a Citizen A20. And then on the other side, we kind of consolidated all the L12s into one room. So I have 4 of those in a same 30 by 30 size building. And then those 2 spaces are connecting, but it's about 10 feet in between them. So we have storage and stuff in that inner part, and it's working pretty good so far. It's nice to have all the same kind of machines in one area. We were getting, I had 2 in the one side and 2 in the other, and it was like, it was a little confusing. So now I think we're getting a little bit of a flow going, and yeah, I'm really proud of it. Like looking at a row of the same kind of machine, I have 4 of them, and it's like, oh yeah, like it's starting to look like honest to goodness Swiss shop. So it's kind of funny.
That's awesome. And then you also just recently built an outhouse for your compressors. How did that go? And what's the whole story behind that?
Yeah, so we had that building. It was like a garden shed almost, but it had a concrete floor and it had block walls and like a really low ceiling. And we're like, hey, I said to my dad the one day, I'm like, we could just put the compressors in there and like get them out of our face and it'd be fine. And then I was kind of like half joking, but then he's like, all right, we're doing it. And he got his our local contractor that helped us with some stuff. He just had him go nuts on it basically. And it really turned out nice. Like we raised the ceiling and built like a nice peak roof on it and painted the floors, painted the inside, made it really like top notch. And then finally, I think we started that about a year ago. And then about 3 weeks ago, we were able to move the 2 compressors into that building and finish the underground piping and do all that stuff. So yeah, that took a while, but definitely worth it because the compressors are, all the heat and the noise and everything is away, and it's pretty cool.
So any lessons learned? Because you went RapidAir with that, right? For your whole shop now?
Yeah, so we have a 2-inch trunk line that runs from the compressor shed up through both sides of the shop, and then it kind of terminates and goes upstairs to our inspection room. And then we have 3/4-inch branches that come off of that at every machine drop. It's very nice. I like it a lot. Our electrician did that install for us.
Oh, interesting.
And it seems like the bigger pipe, I don't know if it's particular or what, but we have had a couple sections that leak, and he had to go back in and kind of fiddle with the O-rings and reseat everything. So it's not super, and that may be just due to kind of the nature of the run we had where, maybe the pipes are a little bit in tension or compression or something, and that causes that. But it was a little more finicky than expected, but overall it's an awesome system. So yeah, I recommend it.
Okay. Yeah, I know we had just looked at it recently now that we moved the whole shop around for the new brother, because we only had one branch just coming off the compressor for, we started with just the kitty. And so we were like,
Yeah.
oh, we just need just enough for the kitty and an airline. And then it was like, oh, well, now we got two machines and now we need to run a whole loop around the shop. And it was like, oh,
Yep.
well, maybe we'll go RapidAir. But because we already have half the shop in copper, it was going to be like, I don't know, $1,100 to do the whole RapidAir, or
Yeah.
it's like a few $100s to do the rest in copper. And we're like, all right, well, RapidAir the next shop that,
Yeah. I hate to think what we spent on that. Dad was buying parts and stuff, and I didn't even ask. I bet it was expensive.
Yeah. Well, I reached out to him. I was like, hey, do you guys do any like discounts or like sales I can wait for? And he was like, usually our discounts start at like $3,500 or $4,000. Like, well, okay, never mind. Thanks anyway.
Yeah, it's one of those things where like you kind of put your big boy shop pants on and you're like, we got to do this. Well, for the longest time we had basically blue rubber hose everywhere, and we just had it like zip tied to conduit and running it, and like it was a complete like rookie home gamer job. And I think I'm not sure what well, we were just like, we got to do it right. And that was part of our electrician being willing to do it. The rubber hose is a like, the machine's coming tomorrow, I need air to it. And graduating up to like a thought out system, we needed help to get to that point. And the fact that our electrician was able to do it made it happen, but definitely worth the investment once you kind of commit to it.
Totally. So anything that you would change now that you have it in? Any more drains, or do you wish you had more drops than you put out or anything?
We're gonna have to change it because the air system was pretty much done before we had any of these machines move last month. So we kind of have some pipe that's just hanging from the ceiling right now. So we're going to finish the move next week, and then our electrician will come back in and ask us where we want everything. And then at that point, he'll terminate things that need terminated and then run new drops for whatever machines that need it. But it seems to be pretty flexible. I mean, you just kind of undo it, cut your pipe and put it back together. So I don't think it'll be an issue. What I did do is on all the, where the line terminates into like a manifold block, I bought 8mm OD. Yeah, 8mm OD poly tubing. And then so I do push to connect from the manifold to each machine, the black 8mm, I guess, polyurethane tubing. Oh, that's really nice. I really like how that turned out. Because then I'll even do blowguns with that, and it's not like that yellow springy hose, but it does give you a little more flexibility, and then you can cut your size to whatever you want and plug it back in, and it's kind of a not a big deal. So and then a lot of the Japanese machines are kind of in that they're running all those push to connect fittings anyway, so kind of blends in with all that stuff. So
that's really cool. So what new machines have you gotten since the last time we talked? Because I know you just put the LFV badge as your most recent post. So
yeah, so that is, they sent those badges out ahead of the machine coming in. So that machine is coming in next Thursday. I just got word today. So we're gonna pull the robo drill and the Haas mini mill out into the driveway, and then we're gonna snake the L20 in and then put the mills back inside. So that L20 is the first new machine we got this year. But last summer we bought 2 used L12s that are over on the other side of the shop. They popped up at a time on the used market where we kind of were looking for something. And then the one popped up, and we're like, yeah, let's jump on that. So we bought that. And I think like within a week, our dealer, or the rep for the dealer, sent out the other one, and we're like, yeah, we'll take that one too. Which was funny because I think I had emailed him about a machine maybe a year or two before that, and I was like, "Hey, what's the price on that machine?" And he was like, I think he sent me the price, and I'm like, "Okay, thanks." And then he was like that. Him sending the price was basically a contract to buy in his mind. Like he was very annoyed that I didn't buy that machine, and I was like, 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 what do you want me to do? So I was like, okay, that guy's a little shady. So let's not deal with him. Well, and then a year later, we're buying 2 machines from him. And he got a little bit bent out of shape because he must have some deal with his buddy in a trucking company, because he was very offended that we used our own truck. And he was just trying to make life difficult for us. But it ended up that both the machines were, well, the one was in really good shape. It was just a little dirty, but mechanically it was really good shape. It had similar hours to a machine that we had bought new, and it was like within 80 serial numbers from that machine. So it was like we were really comfortable with it. And then the other one we got, and it had clearly been on fire at one point, which is like, okay, like, hey, I set a machine on fire. I can't talk too much. But like weirdly, it was very clean. Like we wiped it down. It was dirty when we got it, but it cleaned up nice. And so, you know, it had like 30,000 hours on it when we got it. And then the other machine had like 14,000 on it. So twice as many hours, but at the end of the day, it's making good parts. So yeah, we got pretty lucky with those 2 used pieces.
Well, I imagine that hours on Swiss machines is kind of out of the usual for used machinery usually. Like, because if I look at a CNC mill, I'm thinking a 40-hour shift for a year, you know, that, and then calculating off of that, whereas you can run those unattended for so long.
Oh yeah, absolutely. And I think that's the difference. The one with 30,000 hours, I think, was running 24/7. But the first one we bought that summer was more similar to the way I run them, which is probably about 50, 60 hours a week. And it was probably, and from what I could tell, it was in a shop. They were job shopping it and running short runs, and it was probably waiting on the operator most of the time for setups and that sort of thing. So, you know, that's fine. My machines don't have a whole lot of hours on them. We don't do overnight runs all that often. So it was sort of in line with my expectations. But, you know, they're built for 24/7. So it didn't really faze me either way.
And is your new one a linear motor machine?
No, all the L12s have servos and ball screws. The only ones with linear motors are the RO4s. So the 2 older ones that I have, they have 5 linear motors and then 1 ball screw on the subspindle Z-axis.
What about your 20 that's coming?
Yeah, the 20, same things, a ball screw and servo motors. So,
okay.
And then the new RO4 we have that we got 2 years ago, they actually went a little bit differently on that. So the Y-axis that holds the tool posts on both sides, those are now ball screw, and the only linear motors are the X. So that keeps your accuracy on your diameters. And there's a linear motor on the main spindle Z, and then the sub spindle's a ball screw. So they kind of, I think what that was a safety concern, because when you power the linear motors down, they didn't have brakes on them. So they would potentially, they have air cushions under them to keep them in place. But I think they must have had some issue with that from a safety standpoint, because they got away from that and went to a ball screw to keep that in position without power.
Gotcha. And they just don't put linear motors on the bigger machines for torque? Or
yeah, I guess that's what it is. I would love that. That would be awesome, because they're so fast, and like you don't have any wear on them, and they have glass scales, and like they're just so cool. But yeah, I don't know. I think it's probably I would guess it would cost more too. That would be my guess than just an off the shelf servo and ball screw.
Yeah, definitely. So I don't know how much you can share, but this job that you've been preparing for forever and now you just got, how long have you been preparing for that? Or how long have you been kind of in the process of trying to get this work? And are there any lessons or, you know, things you've learned about being patient and working with a customer on a long-term deal like that?
Yeah. So we got the drawings for that job August of 2019.
Wow.
And we come to learn as we kind of got through the process that they'd sent those drawings to 17 other shops, and we were the only ones that quoted it. And someone asked me, they're like, why would that be? Like, how come no one wants to do this job? And I was like, it's pain in the butt. Like, there's nothing fun about it. But it was very much like a challenge, and we knew what this product was replacing, and it was a very big project in terms of like the previous version of this product was probably being made for at least 20 years. So we thought if this new one is improved, you're probably at least looking at 10 years for this one. So it's worth doing a little bit of investment up front to see if you can get a piece of that. So what we did was we quoted it and had a plan to make it. And then I think it was till about Thanksgiving, so about 3 months till I programmed it. I spent Thanksgiving weekend, like Friday and Saturday, in the shop programming that one job. It's one part, and there's 2 other part numbers that go with it, but just this really one complicated one. And we actually got it to work, and they were pretty impressed that we succeeded. And then the nature of the part is it needs a really high surface finish requirement on the end. It's like, imagine about a 1 millimeter by 1 millimeter surface has some surfacing geometry, 3D machining geometry, and that has to have like a 4 finish.
Wow.
And I was like, well, you're going to need to surface that, right? So I made a little sub program in Fusion to do the surfacing. And then I programmed the rest of the part by hand, knowing that it's very long and slender. So it's about 2.5 inches in length over this really thin area. And it tapers from that 1 millimeter square up to about 3 millimeter square. But it's kind of a gradual taper over that length. And that had that be a pretty good surface finish over that length. And it's square with corner radiuses on all 4 quarters. And so what I did was I programmed it in about 1/8 inch long segments, so I could control any tool deflection, and I could work with the guide bushing to make sure that the part stays on tolerance, in terms of the form that the print required. And it turned out that the part goes kind of across the center line too. So it starts on kind of below center line. That 1 by 1 millimeter square is below center line on the front. And until it gets on the back, it's on the other side. So what we realized is that we're machining off center on this round bar, and you're opening up all the stresses in the titanium, and this thing's it's twisting and it's curling. So I could program out the twist with a macro. Every step I rotate the C-axis, a little bit. I can't program out the twist kind of up, because it would make everything way too complicated. But so anyway, long story short, we were able to get something that the customer was actually pretty impressed with. We did the 3D machining on the tip, and then my dad came up with a finishing tumbling process that basically gave that 3D surface like a mirror finish without any handwork. So that was pretty impressive. You have this like 5-inch long part that's very thin on one end, and then you throw it in a big tumbler, and it comes out, and it's not only not destroyed, but it's like mirror polished. You're like, oh, that's pretty cool. Yeah. So we kind of got some goodwill and got confidence that we were at least on the right path there. And then since then we made probably like 15, and then we made 30, and then we made 100, and then we made 200, and then we made like 150. And now we've been making a couple hundred the last couple months. And it's been a learning curve. Kind of the customer would always ask, like, what's your tool life going to be? Or, how do you know when to change tools? And I was like, I don't know. I don't know how this is going to go. I said, you really got to make a couple thousand of these before we even know what we're going to run into. And we're actually getting there, and it's actually kind of settling down. I thought it was going to be a lot more volatile than it is, but I've been making like 20 of them a day for the last probably 4 months anyway. And it's really going well. I forgot to leave. I left out that the cycle time is like 22 minutes on this part.
Oh, wow.
Yes.
Unlike Swiss.
No,
territory.
right. So it's the live tools. I have 4 live tools, and then actually five live tools, and they're on for probably 90% of the cycle. So it's all just sitting there milling and corner radiusing and yeah, it's just basically it's hardly a lathe at that point. But yeah, it's easily the most complicated part I've ever made. But it's satisfying to know that we kind of achieved the goal that we set out to do.
Yeah, that's pretty amazing. I mean, I imagine that coming from your normal work, that must be a little frustrating, having to use your machine like that. But I mean, I hear a square with rounded corners, and I'm like, well, there's not much turning there, I guess. Like, you're roughing maybe with a turning tool?
Yeah, so I pre-turn everything, and even that kind of was challenging because I was trying to come up with like a rough turning that would give me some strength there. So I'd radius out all the turns so that my tools could finish right up to that radius and give me as much support as I could get. But then I'd go in and turn again, and that was throwing that kind of difference in pressure as I started turning. That radius was messing up my turn tool, or messing up the finish of that part of the part. So it's been a little bit of a learning process trying different things, and which is difficult to do when it's 22 minutes because you try something and you got to wait half an hour to figure out if that was even a good change.
Right. So as you're building up to like a project like this, kind of jumping into one of our questions from Sequoia Manufacturing, he says, talk debt. To what extent are you using debt in terms of purchasing new equipment? I know that you're a big Tim Ferriss fan, and no debt last time we talked. How do you approach tooling up or equipping up for seeing, a big job like this coming down the pipeline?
Yeah, so that was actually a major part of this project. Was our customers really, they had an estimate at the beginning, which was like, I think they wanted 1,000 of these a month.
Oh,
we're
wow.
like, okay, 1,000 a month. Like, all right, we kind of understand that. It ends up being, I think, like 70 a day, something like that. And you're like, okay, kind of back into that. That would probably be like 3-4 of these machines, making them. At that point, we really weren't even sure what the cycle time was going to be. So we were working off estimates. But as we moved farther along, the customer really actually quadrupled how many parts they wanted. So they're like, 4,000 a month. Yeah, 4,000 a month. It's like, okay, like that's going to be a problem.
That's like your whole shop right there. Like,
Well,
have
that's
to be
like,
just
yeah,
that. Like,
yeah. And then it's like, well, we're probably not going to do that. So we worked out kind of an arrangement with our customer that kind of coached them up on how to make some of these things. And, if they want to build out their Swiss capabilities, this would be a difficult one to start with, but at least you kind of jump into the fire with it. So that's kind of the arrangement, is we're going to make some and they're going to make some, and maybe we can get to that 4,000 number together. That's sort of what prompted the kind of the impulse purchase of those 2 used machines last summer. Was like, we need machines and we got to get them in here quick. Luckily we had cash for those 2 machines kind of in hand. We were saving up for a new machine, but you can buy basically 2 used ones for a new one if you have the cash. So yeah, our perspective has changed, I'll say, over the time that we started. We started with the Citizen A20, and we did what was called a lease, basically a bank loan tied basically back to that equipment. So we leased that machine as our first machine, and that had like a 5-year term. And then we did the same kind of finance arrangement on our air compressor, our inspection system. What else? Probably our Haas mill. So we financed probably the first 4 or 5 big pieces of equipment. And then even the first L12 was financed. So that takes us to about 2007. And then when we got to that point, we with a couple machines running, we had enough cash flow where we could start kind of saving up. We were able to, pay salaries and pay overhead and stuff. And then we were able to start saving up for equipment. So that was 2000, or what I say, 2007. I met 2014. I was thinking my daughter's 7, and we bought the last machine we financed when she was born. So I got the number switched. And that was 2014. And then I think in 2018, yeah, 2018, we bought an L12, the one with LFV that we have. We bought that one for cash. And then everything since then has been cash. So
That's awesome.
yeah, it's kind of a mental mindset. Like once you, like, I didn't think it was possible when we started out, like it was very daunting to save, $100,000+, hold it in one spot long enough and then buy a machine. But now it's to the point where you have enough of those machines running, you almost can't help but do that. It's like that L20, like we're buying that kind of because we got to do something with some of the cash that's being generated. Otherwise, it's going to go away in taxes. So
Right.
you get the depreciation, and then you get to build out the business and keep things modern and kind of moving forward.
So speaking of 179 depreciation, you also bought a truck, and we had kind of talked over DMs about that because you have to be over a certain gross weight for it to count. And
Yeah. Luckily, my wife looked that up before we did it, because I think my dad saw that on the lot. I was like, I think he sent it to me, and we're like, yeah, let's get it. And my wife's like, okay, yeah, that's fine. You can get that one. I was like, okay, good. I wasn't asking.
Yeah, I know that like the F-150 is like the highest selling vehicle in the world, and I think a lot of that has to do with businesses buying it for 179 depreciation, because I think it's the same size as your truck about.
Yeah, I could believe that. Yeah, that's silly, but I mean, it makes almost no sense. You could run a decent sized machine shop with a S10 if you wanted to, or a Colorado, but
and with your part sizes, I mean, you could deliver them in a Corvette and you'd still be all right,
Yeah, that's a pretty good idea.
So you had mentioned your inspection room. Let's talk inspection. Josh Hacko asked Kian's IM system thoughts. Have you added anything to inspection? What goes into all that inspection, especially, inspecting a 4 finish? That's another interesting thing, I would imagine.
Yeah. So that's kind of funny that IM system, it's that same project that was, the customer actually just dropped that off at our shop and was like, here you go. What they did was they wrote, there's 3 part numbers in that package that we're making, and they wrote Kian's programs for all 3 and put the system in our shop. So there's basically no excuse for a non-conformance, because they've given you everything you need to inspect that. That really complicated part that we make is, it runs, I think it's like 1:30 on the Kians, and we've been 100%ing them. So we have a 10-piece fixture that we can set 10 parts in, and the Kians will just sit there and run for about 10 minutes, I think it is. It's really cool. I have like such a love-hate relationship with that thing, because for the first year of us having it, it was just rejecting all my parts, and I didn't know why. And like, so what they're doing in that program is that system can make Z measurements with autofocus.
Oh, really? That's cool.
Yeah. So it was like dropping a point on the surface and then moving along that 3D machine contour at the end of the part, the small end with the high finish.
Mm-hmm.
And it was dropping points on that curve and basically measuring, I think it's 2 or 3 points. And if those points don't lie on the curve that the print calls for, then it would reject them, which is fine, other than that very high finish, which like reflects off any light and really plays hazard with that. So we were in like a protracted like discussion of, the shinier the parts, the better per the function of the device, but the more matte and less shiny, the Kientz is happier. So we've kind of had to walk this fine line, and I think we've figured it out because the Kientz has been running pretty good the last couple of days. So we kind of scaled back our tumbling process to leave the parts a little bit less than a full polish. There's a little bit of a machining texture left, and the Kientz likes it, and the customer's fine with it. So that's kind of where we settled on that. I still haven't had a whole lot of time to develop my own programs for the Kientz or really even mess around with it, which is unfortunate because I think it's a really cool thing. It's just, there's so many options that it's almost overwhelming when you sit down at it to like, oh, I'll quick set up this little part to inspect on, and it's like 15 minutes later, you're like picking the angle at which the light is shining from the diffuse, you're like, I don't even know, So we have a really good engineer at our customer that wrote those programs. So if there's anything I need, I'll usually ask him and see if he can help me with a change or with any, and he'll even defer back to Kientz. He has a really good, I guess, sales or support person that will sit down and help him go through those programs because he's spent a lot of time on them, and they're really, a lot of those programs are like, if you draw them or develop them off of a part, it's fine. You're like, okay, it measures this part. But then if you sit and think, you're like, well, the print, might have a pretty generous tolerance on different aspects that you'd never use the whole tolerance, but your program really should be able to compensate for that. And I think it takes a lot of talent to develop a program that really can handle the variation that a part could have over, just programming it off of a part that is going to more or less be that same way because you're going to machine them all the same way. It's just, it's almost like a whole nother field of study, to get into.
Totally. Yeah. I would love to get more into a Kientz system or play around with them, because my only interaction is like super cool demos at like INTS or, what you've showed or what Area 4119 or 419 has shown. That, and then coupled with like the most clingy salesman in the business, you like request one document from them and they're like emailing you every 30 seconds for the rest of your life. So
it's insane. I have okay. Well, anyway, I was like, my customer gave me one. I do not need another one. I'm not going to buy another.
Right. Yeah, exactly. So are there any other things you've added to inspection, or how do you guys inspect like that surface finish? Or I guess actually you said that your customer allowed you up to that certain surface finish. So maybe can you talk about working with a customer on an issue like that and going back and forth and keeping your cool? Because I know a lot of us, when we deal with customers like that, where they're like, oh, well, I want it perfect, but then it also needs to be like this and this and this, it can get very frustrating as a machinist.
Yeah, that was probably, out of the 2 years we've been working on, that was probably about a year of it. We got to the point where I was engraving serial numbers on each part because I was getting very confused I was trying a bunch of different things, different tool paths, different step overs, different feed rates, all this kind of stuff, just to really dial in the 3D surfacing that I was doing. Because I'm not a 3D surfacing guy. It was really the first production part that I was doing anything like that on. And then even to that fine of a finish. And the customer would be like, or one of the engineers was like, this part, this is perfect. Make them all like this. And you're like, you understand, like, that's one sample. I cannot make them all like that. Like, first of all, I don't remember what I did on that one, but second of all, there's going to be variation. How much variation can we get away with? So I think we kind of learned, well, we were fighting the surface finish fight while we were fighting a dimensional fight with the Kientz, because it was, as we increased the surface finish, the Kientz was kind of behaving more erratically, and we needed to get the dimensions right and then kind of bring the surface finish along, versus we had the surface finish from the beginning, but we couldn't get the dimensions right because we couldn't measure them. So it was sort of a 3-part challenge of the part, the finish, and then the measurements. And one of the sticking points was the model. The model was made, it's kind of hard to describe, but the model was made to one side of the spec basically. And they said you could go the other way as much as you want. You could remove more material and that's fine, but you can't remove any less material than the model. And my toolpaths were taken off the model and I was hitting it like right on the edge and I would bounce out occasionally. And I was just like, I don't know what to do because the surface has sort of convex and concave features. So I couldn't think of a way to compensate. Like if you change the tool cutter diameter and reposted the code, you could change the inside, but then it wouldn't blend with the outside of the other parts or vice versa. So I was like, I gotta work with, basically nominal geometry. And then finally, after a couple months, they said, okay, well, you can have room on the other side of the spec. And basically, as soon as they did that, my parts were consistently in the range that they needed to be. And then we just kind of dialed the finish in so that the Keyence was happy and kind of put everything together. And I think since then, we've had probably almost about 1,000 parts that no one's had an issue with. So I'm pretty proud of that.
That's awesome. That sounds incredibly tough to maintain your cool and deal with all of those issues and know that there could be a big payoff at the end of this, but that it also could just blow up, at any moment.
Yeah, it's hard to, sometimes you're dealing with someone that has sort of the understanding of machining, and then sometimes you're dealing with people that don't. But the designer and the engineers we were working with were really good. And although they couldn't really understand exactly what I was telling them, I don't know that I was always communicating the best, but they were at least open to the idea of like, this is the best I could do. Like, how do we move forward? Because I can't necessarily, I have constraints too as to what I'm working with, and we got to kind of find something that we can all agree on. And I think we've done that.
Yeah, it sounds like it. So in addition to the Keyence, I think you posted, I can't remember if it was your stories or a post. Zeke Johnson asked to use any kind of optics in the shop, like low-powered microscopes. I think you posted that you have a stereo zoom or two, which I do as well, and I love it. But I'd love to hear what kind of microscopes and optics you guys use.
Yeah, so we have, I'm trying to count them all. We probably have 4 stereoscopes in the downstairs. I have one here at home with me. They're 0.7 to 30 power. I'm really comfortable with those, and that's what I spend my day on. And then my dad and my wife have Lynx scopes from Vision Engineering, so they're kind of big old scopes, and they have like a rotating element inside. So there's like a little motor that spins some sort of optic in there, and that bends the light 90 degrees then. So you're looking straight ahead and the image is directly below you. So that's nice they're spending a lot of their day at the scope continuously. So that's nice for them. I don't care for that personally. I'm very comfortable with the Bausch & Lomb. We have Bausch & Lomb, and we have a couple like stereoscopes. That's kind of my everyday. But we tried I think it's a Mantis.
Yeah, that was what I was just going to bring up. Is I've looked into the Vision Engineering Mantises because they can be had for not terrible money on eBay. It seems like
they had a weird. We kind of did like a side by side. We had our rep bring out one of those, and then he brought out a Lynx. The Mantis one had sort of a weird, almost like a spherical distortion. If you were looking at say like a dowel pin or whatever, the dowel pin would look almost bent underneath it.
Oh, really?
And yeah, it was very kind of off-putting. And maybe the inspection or what people were doing under the microscopes, maybe that would not be important. But for us, it was very weird. Maybe if you're doing like assembly or electronics or something where you weren't caring about the form of the part, but when all your parts look bent, it's hard to find the bent one then, if there is a bent one in there.
Well, and they're doing a lot of deburring under those.
Yeah. So I do a lot of it, and occasionally my wife will do some. And then dad he's looking at more for cleanliness, and if there is a burr, generally he'll I guess he'll pick it off or set it aside and then come back and revisit it. But he's really just looking for presence of burr or particulate or anything like that.
Okay. Well, since
Not
you
so
brought it up
much. Yeah.
about cleaning, you added some new cleaning tanks as well. What's the whole deal?
Yes. So we added a vapor degreaser. How long ago was that? A couple months ago. We had 2 vapor degreasers that we had bought used from HGR surplus, just to see if that was something that was going to be good for us. And it turned out it was. It was really effective at cutting oil off and creating clean parts without doing all the washing that we do normally. So we added that basically as a support piece for this big project that's coming through. We wanted a new degreaser that would be more reliable and quieter. The other ones were very noisy. So they have basically a heated solvent tank, and then above that they have a refrigerated coil that condenses the solvent as it boils off. So you put the parts in the solvent, and then the solvent cuts the oil, and then as you lift them out of the solvent flashes off and condenses on the coils and drips back down into the tank, and it leaves your part clean and free of anything basically. So since our parts basically are uniformly coated in oil, the vapor degreaser is a quick way to get them clean, and then we can process them after that. So a lot of our parts will either go into the tumbler at that point, or they'll go into a glass cabinet, or some parts we can just ship at that point too. And then I'm trying to think what else we've added. We've added a couple benchtop ultrasonics. We're trying something different where we have a couple of the larger console systems, but we're kind of trying to get away from that. We're finding our water usage is pretty high, and we think we can do better and make cleaner parts with just some of the benchtop units. So we're trying some stuff there.
Okay. That's cool. So you mentioned blast cabinet. Let's talk robots. What are the URs doing?
Yeah, so we have 3 robots. The one UR5 is paired with the RoboDrill. So it loads a part into the A-axis rotary, 4th axis rotary on that machine, and does some engraving work, and then exchanges parts every about 6 minutes. And that's done really well. And then we have a UR3 that does the blast cabinet. So what it does is basically there's 60 parts on a table, and then it can pick up the part and load it into a little servo motor rail system that I built, and that just runs it into the blast cabinet and executes like a little CNC program that tells the blaster how long to blast the part. So there's some M codes that turn on solenoid valves to power the guns, and then there's basically a C-axis, rotary axis that can rotate the part. And then there's basically a linear axis that can position the part relative to the guns. So that was part of this project we've been working on. Is 2 of those parts needed to go and get glass bead. So we adapted that system to run 2 different media types, basically a fine glass bead and a really fine glass bead. We spent like a couple months making finished samples for our customers. So we bought like one of every media and blasted like 2 parts, and then wrote which media we used, and then changed the cabinet out, different media, blasted a couple more, and then they picked out which finish they wanted. So now we can actually change that cabinet over in about 10 minutes between 2 different medias, which is pretty cool. So we can do 4 different part numbers now on that robot without really any changeover at all. So pretty proud of that setup. Pretty flexible in allowing us to get some of that work without putting the labor into it.
That's great. So what are you using to drive all of the solenoids and everything?
So it is a Moog Animatic smart motor. You should look them up. They're pretty cool. They're not super cheap, but what they allow you to do is all the electronic drivers and everything's built into the motor, and they're not really any bigger than a normal like NEMA. They're NEMA 23 motors, and they're not really big at all. And so you give them power, and you can write a program in their, I forget what it's called, language. It's you're basically just programming it in terms of encoder steps, or you can use they have a CNC program, which is a little janky, but it's effective. And you just plug it in USB into a laptop, and it runs, and you could write CNC programs, kind of any configuration you can think up. And then, so I did that and basically daisy chained the two motors together and then plug them into a laptop, and then just write a CNC program, and actually gives you all that functionality without anything other than a power supply and two motors. So that was pretty cool.
How'd you end up on those versus, running some Linux CNC or,
Yeah,
whatever?
we had a vendor that carried them, and just kind of right time, right place thing. We bought a couple Parker linear actuator things from him, and then he recommended these motors, and yeah, just seemed to work out.
That's awesome. And you can plug the solenoids into them as well and have them control the solenoids.
There's a breakout board that I bought, and there's like an IO pin out on the motor itself, and yeah, it all kind of just worked.
That's really cool. I like the idea of, that seems like the simplest and lowest path of resistance to having to, automate something like that.
Yeah, exactly. And it was like, I think the tendency would be, if you're buying a robot, like, oh, just get the robot to do it. But we actually did that CNC part of it first, and we were manually exchanging the parts. So we kind of did the bulk of the automation as far as the blasting before the robot, and then the robot just kind of took over the human part of it at that point. But I didn't want like a $30,000 robot getting glass bead all over it constantly.
Yeah, my guess is the wrist joint wouldn't be too happy about that.
Exactly. I wanted something cheaper that could get in there and wear out or break. And I'll probably go in tomorrow and it'll be broken. But as of today, that thing's been pretty darn durable. We've been running it for probably 4 years now, and it's same motor and same setup that it's been. So I'm pretty impressed with it.
Yeah, that's fantastic. That's lasting that long is a true test of automation, because it seems like, getting something to work for a year is like amazing. And then having it last 4 times that is really impressive.
Oh yeah. And I think part of that too was like, if you look at some of those things from perspective, like, what do I know? Well, I know CNC programs. Okay. Like, can I do this task as a CNC program? And if you can break it down to that point, you're like, yeah, it's just a matter of write a CNC program to do whatever you want. And I think that was a quicker way for us to automate something than if you would just jump right to the robot and say like, well, now I got to like learn how to program a robot before I even start on this task. It's just, sort of baby step your way into automation piece by piece, basically.
Right. And then what about the third arm? Because the last time we talked, you were kind of using that as a test bed for future automation.
Yeah, so that one, it's kind of still in that status. I have a Cognex camera on it. I wanted to kind of see how that worked. So we had it locating parts, picking them up, and brushing a thread, deburring a thread. We've kind of gone away from doing that. It was kind of an extra process we didn't want to do. So we've gone away from that, and that is waiting for at least two projects I have in mind for this project we've been talking about, that I have a couple finishing tasks that need to be automated. So next couple of weeks here, I'm hoping I'll be able to get to that. I bought a spindle off of eBay. Basically, it's going to be a fancy Dremel tool to do some kind of finish blending of the part with a Kratex wheel. So that's on my list of things to do. And I'm going to take that robot and kind of reconfigure it for some finishing work.
Cool. I've got such a love-hate relationship with Kratex wheels. Like, you can make parts look so nice with them, and then screw up parts so massively with them if you do it wrong.
Yeah, I had never used them before, and I bought like a sample pack, and I was like, I was trying to see what they could do, and what I need to do is blend basically a stop and start point of an end milled finish. It kind of leaves like a little bit of a step line, basically, where you make a pass and then you meet that pass and make another one. And I'd like to get a nice consistent finish over the length of that. So that's what I was trying to do. And I think I'll be successful doing that. And then I have some heavy burr that's on the part too. And I was like, I wonder if it'll take that off. And I just like went for it with the wheel. And it did. It took it off, but it also like chewed up all the edges of the part too.
Exactly. Yeah. Like you can always do exactly what you wanted to, but then it's like, oh, I was lifting the thing out and I clipped a corner and it's like, oh, I just scrapped that part.
Yeah, exactly. Yeah. There's an edge on this part that it's not very tall, but it has to remain sharp and like square. And wouldn't you know, that thing's like missing. It's like completely gone. I'm like, okay, we got to stay away from that part of the part with this thing.
Yeah, it's tough. So speaking of finishing, Tom Machinist had a great question, which is what is the ratio of time and man hours on like inspection and cleaning and finishing parts versus runtime? And it sounds like maybe this 22-minute part might be a good or an outlier on your normal parts.
Well, I think I have like 22 minutes of deburring on it. Not really, but almost. So yeah, I think for that, what we've been averaging is, and I guess maybe the automation might kind of, you might be comparing apples and oranges, but so far it's been me doing the machining and my dad has been doing the finishing. So it's about 50-50 in terms of man hours. The last year or a year and a half, 2 years, I don't know, I forget. But my wife has been helping us. So we've had more finishing capacity, but I've also been adding equipment. So it's, I think with CNCs and especially Swiss, it's easier to make the parts than it is to get them out the door. But that also can be a function of whatever market you're in. There's probably very, very few percentage of our parts that can be shipped off the machine. Usually there's some sort of surface finishing we need to do to them, tumbling or blasting or something. So passivation, that sort of thing. So there's a lot of secondaries that are important, but are also labor intensive. So we've automated a lot of that. That's why maybe a normal shop would have, maybe 2-3 people for every machinist. I think it can vary based on the work you're doing, though.
Yeah, for sure. I know we've got a few people in Deber at my day job, and man, I give them so much props because, like, when I first started there, they have you on board at every area in the company, and I was in deburring for 3 or 4 days, and it's like, man, I could not do this as my job, or as my only job. I would lose my mind. But there's some people who just do it so well, and it's really impressive.
Yeah, that's kind of, yeah. I do a lot of our deburring that can't be done other ways. So I do have that love-hate relationship with it. It's one of those things where it's like, well, why aren't we doing this in the machine? I was just talking to Dad about that today, that I have a job here I'm looking at that I have to deburr, and it's like, we've been doing it for 6 or 7 years. It's like, well, why aren't we doing it in the machine? It's like, well, if we would, it's not as easy as it sounds, just deburr it in the machine. It's sort of a Y-shaped part with internal passages that meet up on an angle. And I've been sort of putting off trying to do it in the machine because it just seems like it's not going to go well. But, I guess if I don't try, I'll never do it. But He was egging me on to actually do it today. So,
well, I know even for prototypes, like I had a part over the weekend that I was doing, and there was like a radius into a radius, and so like they had that line between them, and I was like, oh, I could pick this off with a 16th ball or something, and I was like, nah, I'm gonna be lazy and I'll just hand deburr it, and I got about halfway through the parts, and I was like, man, I should have just put the tool in and written the program, because this is a pain in the ass.
Yeah, you never regret putting the deburring passes in. Like, you're always like, yeah, I'm glad I did that.
Right. Yeah. You're like, it looks better. It's less work for me. Like, yeah, it was a little bit more work up front, but it's never worth the hassle in the back end. The other question you had that I thought was interesting, I want to dive into. I didn't realize you had a Mark Forged.
Yeah.
So how's that going? And he says it seems very expensive to run, but how are you liking it?
Yeah, so I love it. It is very expensive. I wanted a 3D printer that I didn't have to become an expert on 3D printers. to use. When I bought it, I was very kind of leery of like, everyone was like, oh, modifying it. I'm like, I don't need another hobby. Like, I don't have time for that. Meanwhile, I'm like, I should get into 3D printing, like get a Prusa or something. But I very rarely have anything that goes wrong with it. Like, you give it the print and it prints and it's like a non-issue. The plastic is really good. They give you like the airtight case and the tubes and everything. So like, you don't have to worry about moisture too much. Yeah, I'm just really happy with it. I needed it to print the things that I needed for work. So it's not like a frivolous thing for us. But then everything that I've made on it, I've been really pretty impressed by. We use it a lot for masking parts. So we'll print up masks that go onto parts, and then we'll blast them and then pull the mask off, and it'll leave the finish underneath. And the plastic, we have one that we put the mask on and we blast 46 grit aluminum oxide, which is really abrasive, and the plastic holds up really well. And the shape of the mask is really a complex 3D form, and they print out and they're pretty darn consistent. They fit on our parts, and yeah, I put zero time into like sizing them. Like, they just print the size that they should be. So yeah, very happy with it.
Yeah, that's kind of echoes the sentiment that Jason from Prometheus had as well. He said it's just prints, like, yeah, which is pretty amazing. I know I've said the same thing about like the Form Lab stuff. Like, everybody's like, oh, they're so expensive to run for resin printers. And it's like, yeah, but they just work. Like, I just hit go and I come back tomorrow and there's a part there. Like, it's cool.
Yeah, you really got to you're either in the mindset of like, this is a goof and I want it to be as cheap as possible, or it's like, if I didn't have this printer, I'd have to machine it or get someone to make it, and it would cost me money. So I might as well spend money on a nice printer and the expensive filament. And that's kind of where I got into. But then it's like, you're in the software and it's like, that's a $51 print. You're like, oh, no. But
it like, even tells you?
Yeah.
Oh.
And you're like, oh, that sucks. You're like, print. And then 24 hours later, it's like, awesome. You're like, oh, that was like the best $50 I ever spent, because I have the part and it's going to work. And yeah, so.
That's terrible. That's like putting calories on the menu. It's like, I don't want to know how fat I'm getting. Just let me eat it. Like,
yeah. Well, you're like, does it? Yeah. You begin to optimize before you print. Then you're like, I'm going to try to get that down a little bit.
That makes sense. So back to Josh Hacko. He also asked, what is the best and worst business decision you've made as a shop owner?
Best and worst. So this L20 we're getting, we probably should have bought that a long time ago.
So what's the spec sheet on this?
So it's a Type 8, which means it doesn't have a Y-axis on the subspindle. It's kind of like the previous gen version of that machine, but we don't have. We couldn't justify it. In other words, we know what it's going to be running, and it's pretty straightforward part. So we bought kind of the entry level machine. But what we bought it for is a deep drilling application, where we've been drilling apart from both sides and potentially leaving a burr in the middle of a part that we've been making for the last couple of years. And we go in and deburr it if there's a burr present, or we kind of brush the inside of it to make sure there's nothing laying in there loose. And what we're going to do with the L20 is drill it from one side with a deep drill and eliminate any possibility of a burr being in there. And then we got the LFV option on it, so I can turn the OD of the part without any stringy chips. Currently on that job, I'm stopping it every cycle to make sure there's no chips on the part, and that gets very old. I've been doing it 1,000 times a month for the last 4 or 5 years.
Oh, wow.
So yeah, so I'm ready for that. But I mean, yeah, the fact that I've been opening the machine door 1,000 times a month, and my dad has been deburring 1,000 of the insides of those parts. Yeah, it was a bad decision to not buy this machine a long time ago.
Okay.
And then the best decision, I don't know. I mean, it's kind of hard to point to. Well, I would say the best decision is having a goal probably for your business. we had a sales goal for the last, I don't know when we started thinking about it, but we had a number in our head that we thought it would be pretty cool to hit. And it looks like this year we're going to do it, but we pretty consistently didn't hit it for the last couple of years. And we got really close last year. It was sort of a letdown I think we missed it by 2% or something like that. So I think having something to work forward or look forward to or work for is a good thing. And I think that's pushed us. Some days you question whether, you really should be pushing all the time to hit a silly number, but at least it's kind of something to focus on and keep in your mind.
I totally agree. Like Brad and I, maybe a year and a half, 2 years ago, started having more serious goals like that. And it's really helped shape the kind of business we want to run. Like you look at jobs and you're like, well, yeah, I could do that. But like, does that get me closer to this goal? Is it going to help me in the pursuit of these goals? And like, that really helps. Cause otherwise you're just like, yeah, I don't know. I'll just shoot from the hip and hope it all works out. And
yeah, I think, if you have a number goal, the tendency could be take everything because that helps you get to that goal. But sort of the next level is like hit the goal, but do it in a way that you're living a good life and you're not taking everything that comes in the door. And I'm struggling with that constantly. It's like you get an email and the part looks good and like you want to do it, but you have to balance that with already being busy and wanting to please existing customers, wanting to keep kind of new customers at least potentially on the table. It's just like this crazy balance, and it's been a struggle the last year or so because we've been so busy, and it's coming from a mentality that we started with where you take anything you can get because you're trying to grow it, to having plenty and then being picky about stuff. It's definitely a shift.
Yeah, it's tough. Well, like the thing that I find I come up against more and more is the opportunity cost of jobs. And like, there's almost no way to quantify that because you can't see into the future, but you're like, oh, if I take this job that I know is going to run for, a month or whatever, but it's low paying, well, it ties up that machine for a month. And like, what am I going to miss in the coming month that could be giant for me? Or I could have zero work and thank God I took this job, but it's tough to work through that.
Yeah. I mean, yeah, exactly. Yeah.
Like that was one of the biggest reasons we kind of bought this new brother, is like with the S700 being our only mill that could really 3D surface and had, was tighter and could really hold tight tolerance parts. Anytime I did jobs that lasted for more than a day or two, I automatically started seeing my queue just start backing up. I was like, This is killing me. And if I'm going to go full time, there's no way I can do this because I'll just be held hostage by what I can put through one machine.
Yeah, it's tough. And I think that's, I mean, that's sort of with for whatever reason with Swiss people or Swiss shops, it's like you always see multiples of each machine. And I like having that flexibility because it is frustrating when you have a job and you're married to it until you can get it done. And whereas I'm lucky enough now that we have a couple of each where I can jobs come and go at different times. And some, well, for instance, that job we've been discussing has been on that machine for the last year now, I guess. Like I just made a decision. I'm like, well, the setup's a pain. I'm not taking it off anymore.
Right.
So
that's on an L12, you said?
Yeah, on an L12. So it's nice too to have that flexibility where you're like, if it sits for a day, that's fine, but I can't be throwing jobs in there every day or every other day because I'm trying to keep the machine running. At some point your labor is worth more than the lost productivity of the machine too. So
yeah, that's another struggle for sure. Like, especially as a small business, you're like, man hours is like the one thing you can't create more of when there's so few of you. So
Right.
it's tough. It's really tough. Let's see. So CG Souter asks, do you see yourself using CAM software for your Swiss lathes, or is hand programming just the way to go? It sounds like you do a little bit of both, but for the most part, hand programming.
Yeah, as far as the Swiss machines are pretty much all hand. If I need a little toolpath here or there out of Fusion, I can do that and then kind of piece it in. Usually you'll see that I'll do that when I'm working on the end of a part, for instance, like the 3D toolpath I was talking about, or some engraving or something like that. But for the most part, I do write all my Swiss stuff by hand. And that's mainly because I've developed a kind of a library of parts now where if I see a part that looks similar to something else, I'll pull that similar part up, change a couple lines, and it'll be ready to go. So I would say on a simple part, could potentially be faster than programming CAM, going through a setup and doing all that stuff. I looked at PartMaker a while ago. It seemed interesting, but it also seemed like just a whole nother thing to learn, and I was expecting it to be like Fusion in the sense that you build a toolpath and then make a change and refresh it and update it, and it didn't seem to be that way. It was like you got to backtrack and start over, and it's like, it's not what I had in mind. I think Fusion could get there. I don't know what they could do. I mean, surely they could drop in the things that would make that work if they wanted to. If I were a better or post editor at all, I could make something that would work for me. I would be probably more inclined to do that than to do anything else at this point. Try to hack a post together that would work for me.
Makes sense. Yeah, we have a license of PartMaker at work, and I pulled it up one day. I was like, I'll just see, why not? Like, and I don't think I even made any usable code. Like, I was like, I am so in the weeds already. Like, I don't know what's going on.
Yeah.
Like the whole Delcam's philosophy of like making curves that you then drive toolpaths off of. Like it just seems so many button presses deep before you actually get what you want that it was like, yeah, I was struggling for sure.
Yeah.
Let's see. Crash Thorn asked, where does the liability fall on medical parts? On the medical suppliers, your customers, or the manufacturer?
That's a good question. First of all, our customers generally require us to carry a couple $1 million policy for liability insurance. So I think it would depend, the answer to that question, on the nature of the failure that's being investigated. I would say I don't know. I'm not a lawyer, so I don't know. But I would say that it would come down to if the part was manufactured per the drawing and you did your end of the deal, it would be on the customer. But that assumes that the part was made correctly. And, at the end of the day, you can't always guarantee that everything that goes out the door is actually exactly per print for some reason or another.
Do your customers flow down inspection requirements like lot sampling and things like that too, or is that up to you?
It's generally up to us. Some will specify and others will just ask what you're doing. I always thought that was kind of weird. They kind of just are okay with whatever you're doing. I guess the thought there is that their incoming is going to be good enough to catch anything that they deem to be a problem, which is good. I mean, like I'm more okay with very, very picky incoming inspectors than customers that don't say anything, because I don't want anyone to take my word for it. I want all the stuff that I make to be scrutinized, because I'm just a person and there's only two of us, and I'm generally the only one doing dimensionals anyway. So if I miss something, it should be not just up to me. It would be a pretty crappy system on the customer side if the only person looking at the parts was the vendor that made them.
Right. They're like, oh, Dan's the man. He's got it. Like,
yeah. So no, I'm all for double and triple checks, which is kind of where that Keyence comes in. It's like, well, if you could lay a part on there and it would tell you, at the end of the process, if everything's good, I think that's like another double check that we could implement. I want to get to that point.
So are you doing 100% inspection on the Keyence, or?
We are on that one part number that we're using it for, yeah.
Okay.
But not on anything else.
So as you spool up, is that going to be a limiting factor? Are you going to need another one from them?
No, which would break my sales lady's heart. But it's only like a minute cycle time to measure the part. So I think we could make a lot of them before the Kientz is the bottleneck.
Yeah, and I suppose you could have the robot load them too eventually if you
Yeah,
want to.
there's triggers on the back of the Kientz to trigger inspection and for it to tell when the inspection's done. So I kind of had that noodling in my head of like doing a couple things with a robot and the Kientz as sort of as part of the cell. So that's kind of on the table.
That'd be really cool. Kelvin at Urban Survival Gear asked how to get ITAR and ISO certified. And actually, that brings up an excellent point that I dropped the ball majorly because you gave me your ISO consultant's number, I believe, or email a while ago. And I was going to have him on the podcast, and I need to reach out because that would be the perfect guy to ask all these questions to.
Yeah, he would be a wealth of knowledge for you. Yeah, I was talking to him last week. ITAR, I have no idea what's involved. I put the ISO note in there because I wasn't sure if maybe Kelvin was asking about ISO and had a typo or something. I have no idea what ITAR is involved in other than I want nothing to do with it.
Yeah, I checked your website. I was like, is he ITAR? I didn't think that he had.
No. No. Yeah. So if he meant ISO, all that really is required for that is, from what I would recommend, is getting someone to help you do it. I wouldn't recommend doing it yourself, but it's just a set of procedures that are implemented basically that describes how your business runs and how you handle certain events, such as customers returning parts or having a corrective action, or how you order material or how you ship product. Just basically a set of procedures that describe all that. And I think the easiest way to screw it up is to do it yourself, because although a set of procedures sounds pretty easy, it can get complicated because there's a standard that describes how those procedures should be written. And it's best left to the people that kind of live in that world.
Well, and you have to do everything you say you're going to do. So you want to be as like short and concise and to the point, from what I've heard, as possible, without you want as little complexity to the system so that you can be sure you're doing everything for when you get audited or whatever.
Right. For instance, yeah, the easiest one is like, say you purchase material and you receive that material in, or the standard says you have to do some sort of incoming inspection. Well, the easiest incoming inspection would be to review the packing slip that came with it and to make sure that it is what you ordered. And that can be to show that you've done that, reconciliation. All you have to do is initial the packing slip and initial the purchase order, and you're done. I think most people would see that as like, well, we need a form to receive it and to document it. And now you have a form, and now that's got to be, and it's like, it's over at that point.
Right. Yeah. You're like, I got to rev control that document.
Yeah, exactly.
And I got to review the rev. Yeah.
Yep.
That's a nightmare. I know the thing that always, like, I've definitely looked into the future of getting ISO or AS certified just to open my horizons to more customers. But there's like definitely some sticking points in there that I'm like, I'm not sure how I would deal with that as a small shop. Like contract review. It's like, how do I make contract review dead simple, or like risk analysis?
Yeah. I mean, contract review can just be you print out the purchase order from the customer, you read it, and you initial it at the bottom. I mean, that's all it has to be. You can let that stuff kind of creep and turn into a process. But for instance, when you get a purchase order, you review the contract or the purchase order and initial it, and then we have to show that we acknowledged it with the customer. So you reply to that email and say, order received, thank you, and then you're meeting the requirements, but you just sent an email. So I think that's where our consultant helped us get to that point without too much of that kind of bureaucratic overhead. And I think it's worth every dollar you pay to them. Now you can get an expensive consultant that isn't helpful. That's not what I'm talking about. But you get a sort of a small business oriented consultant. I think it would be worth it.
Yeah. Yeah. Well, and I think that another trap that people fall into with that is, because I've seen quality management systems balloon because they make a mistake And they're like, oh, I got to put in all of these new things in place to prevent that mistake ever happening. And so they add all these forms and all this review, and like it just, becomes a million pages long. And I don't know if you've read Delivering Happiness by Tony Hsieh.
I haven't, no.
So he talks about this whole period in his life where he goes and plays a lot of poker and finds all of these parallels between business and poker. And one of the things that he says is that parallels in business is that just because you won the hand doesn't mean you did everything right. It doesn't mean you're following the strategy. And like the inverse of that is also true. Like if you lose the hand, it doesn't mean you didn't play right.
Right.
It just means that something happened outside of your control. And so like I think that a lot of us have the tendency like, oh, I've got to do all these damage mitigation things and prevent this from ever happening. It's like maybe this is just human error. Like maybe this is the random fluctuation that happens. And like if it happens more than once, then yeah, you've got a broken process or something. But like I think I see that in machining too. You're like, oh, this drill broke, and then you go and you like half the feed rate or something, when really it's like, well, maybe it was just a bad drill. Like you don't quite know,
Yeah. I see both sides of that. It's hard when a customer is like, send me your corrective action on this issue, and you're like, we're gonna keep an eye on it.
Right. Yeah, exactly.
It doesn't always fly.
Yeah, it's a tough world to be in, like in that middle ground there, for sure.
Yeah.
Josh Hacko asked, why is buying an RO4 the least informed decision ever? AKA, why do most buyers seem to know more about the machine than most sales guys?
I don't know. I think those machines are, well, maybe Josh in the watch industry had a leg up more than I did, but they're just kind of odd ducks, and I don't think maybe they're not very profitable to sell, so they try not to sell them, but they're kind of annoying because they are spec'd with almost no options. So when you buy one, if you wanted to do anything interesting, it's an option, which makes them get very expensive very quickly. And Josh's machine, I think he got one of the first ones of the new generation. He has like all the options turned on, and I'm very jealous. But yeah, I don't know. I think they're interesting machines, but they're probably not the best in terms of, well, resale for one thing. I don't know that I could find a buyer for mine if I if I needed to unload it quickly.
So what would you say is the most productive machine in your...
Our L12s are like, yeah, pretty productive. And I think that gets back to like that L20 being a mistake not having that sooner. I think the L20 will be the same way. The fact that the L12s have live back working, they're compact, they just sit there and run and make parts. So I've been very happy with those machines. Yeah.
How fast do the live tools spin on that?
10,000.
Oh, wow. That's great.
Yeah. Yep.
So that surfacing must be not terribly long then, I guess.
The surfacing on that is done with an NSK spindle on that 3D part. Then the other 4 live cross tools are the built-in 10,000 RPM spindle. Yeah. So yeah, they're nice having that speed for sure.
That's super handy. Well, we already covered shop news and new things, I think, but let's go to the last question I ask every guest, which is, what did you research this week?
Yeah, I put a couple things in here. I was just thinking it would be kind of fun. I don't know, maybe if you have any off the top of your head, but any YouTube channels that are non-machining related. I've been watching a couple, actually a lot of farming videos. I don't know if you ever got into those on YouTube. So like the guys out west with the big Midwest with the big farms. I just kind of draw the parallel of like capital intensive business, usually like family based, a lot of equipment. The interesting thing with the farming is that their equipment is insanely expensive. They have a lot of it, and they use it like a couple times a year.
And so they can't repair it either, really. Or they like, there's that whole battle. Like I think I've seen a few of the farming videos because it was a crossover with right to repair videos.
Okay.
And there's that whole big battle right now where people are hacking John Deere tractors and stuff to fix them themselves and add GPS and automation. And John Deere was trying to lock all that down. And I think it's still in the courts, actually. They're
okay,
kind of fighting that battle.
Yeah, the electronic side of that stuff's pretty crazy. And yeah, it does always seem like they have like GPS modules they like swap between tractors, and that must be insanely expensive because you just be like, well, why don't you just buy one for each one? But it's just interesting how they have to kind of do all their work within a couple weeks of the year, but then their equipment sits. It just boggles my mind. Like I'm okay running, like buying a expensive machine, but then I get to run it all year and make money off of it.
Right. Yeah, it would be like, buying a super expensive Hermley or something and being able to run it for a couple months. And you're like, well, that's it. That's the season of machining.
The season's over.
Yeah, it would be a little tough for sure.
Yeah.
I've been watching a lot of Mustard videos. I don't know if you've seen that YouTube channel. He's a big aerospace nerd and does like amazing animations and deep dives on experimental aircraft from specifically, or a lot of them are from like the Soviet era, because the Soviets just kind of went off the deep end on really weird.
Okay.
Like there was a bunch of ground effect planes which could not fly in the sky, but they generate a really high pressure area between the water and the wings. So they fly like 10 meters off the water, and they could go as fast as an airplane at that level, but carry as much as like a cargo ship. And so they had created, I think there's 2 or 3 different videos on a few different styles of them. And they had a bunch of drawbacks, and, they were all kind of created as the Soviet Union was falling apart. And so they all kind of went nowhere, but they seem like just super cool. Like they had plans for these ground effect plane carriers pretty much that could have carried, a bunch of ships across an ocean 5 or 6 times faster than any kind of normal cruiser or anything like that.
Wow. That's interesting.
Yeah. But I've been watching a lot of that. Trying to think of what else. I think we both talked about the MIT videos. We both somehow ended up on the nuclear power ones.
Yeah, I watched that whole, what's the name of that course? Introduction to Nuclear Physics or something like that?
Something along those lines. And it is
MIT OpenCourseware. And then I got in and I'm like, all right, I'm learning about all this stuff that's on here. So I was watching like all of them. So yeah, that was really fun.
Yeah, that if you want to nerd out about anything, like I cannot believe that MIT gives away all that stuff, because you can get a lot of the corresponding downloads too for a lot of those courses. So you can pretty much take an MIT course all online if you want to for free. Like it's amazing the time we live in.
Yeah. There's no excuse for not knowing stuff.
Yeah. So you also put down deep drilling of titanium. I'm guessing that's what the part you were talking about on the L20.
Yeah. So we're gonna do that job. I've been working on a different job where I'm drilling an 8 millimeter hole about 4.5 inches deep in titanium. And we were using off-the-shelf Goering drill that they recommended. Well, it's not that they recommended, it's just that's what they had for titanium. And I think we're finding that drill was putting a lot of stress into the part. It's a very thin walled part. And then what happened was we have to machine a slot down the side of it and kind of expose that bore. And we were getting a lot of the springing of the wall. It was just kind of opening up. So I had a rep from Nachi come in, and he brought their off-the-shelf drill for that application. And we had about the same results, which I was like, okay, that's good. At least they're the same. And then he took that drill back and it was a double margin drill. He had one of the margins ground off, and then he had the tip geometry kind of sharpened up for titanium. When we put it back in, and the spindle load was like 10% less. It was like 50%, I think. It dropped down to like 40, and we actually were feeding it harder than the Goering. And I did some heat treating on the parts that we had been doing prior to avoid that spring and open effect. And we didn't really see any distortion of the part. So it's kind of promising that drill isn't imparting as much stress into the part as before. So that's been, along with that other part that we were working on, this one that goes with it, has been a struggle over the last couple years. Yeah, year anyway. Getting a hole that's 8 millimeters, I think it's plus or minus 0.03 millimeters. So it's like a thou and tight. 2/10. Yeah. Over its length. And we, for whatever reason, the bottom of that hole is small, and we've been fighting that. But with this new drill from Nachi, we've been making progress. So I'm pretty pleased with how that's been going.
Did I see you were doing those in the Robo at one point?
I do them in the Haas. So we kind of blank the blank of that part off on an L12, and then we turn it around and stand it up and drill it in the Haas, which isn't ideal. It's like almost the world's worst setup, but I'm hitting concentricity. I'm actually hitting hole size now, so I finally figured it out for the most part.
But now you're going to move it to the L12 or the L20. I mean,
well, yeah, I think
the
our
A20?
customer's going to be taking that job over. But if it comes back, we'll put it in the L20. So yeah, that machine will show up right as that job's going away.
Oh, so do you have TSC in the Haas?
We do. Yep.
What pressure is it at?
It's allegedly 300. Some days it's like 300 seems like a lot.
Okay, but you're able to do it. I mean,
But it does it. Yeah.
That's pretty amazing. That's what, 13 times diameter, 14 times diameter, something like that.
Yeah.
Oof, that's impressive.
Yeah, that that Haas is like the redheaded stepchild. Like it's kind of the crappiest tool I have, but man, I've been working it for the last couple of years, and it does pretty good.
That's awesome. And then the last thing you put here was machining platinum. That sounds interesting.
Yeah, so I had a customer email me on Friday afternoon at like 5 o'clock.
Oh, of
and
course.
they're like, we need this part. I'm like, okay. And I looked at it. It's like about a millimeter by half inch long, maybe, piece of tubing. And then I noticed the material was platinum. It's like, okay, this is easy. No quote. And then, because I had looked at a platinum job a while back, and I couldn't even afford to buy the bar stock to make it. And then you really have to like recover all the chips in a pretty organized way. And I was like, there's no way I'm going to be able to do that and make any money on this deal. So I no quoted it. And then the customer called me today, and they're like, we really want you to take another look at this. And I was like, come on. Well, he sweetened the deal by saying that he's going to drop ship the material to me if I agree to do it. So I'm not sure. I'm still not sure how that's going to work, because a foot long of the material, 12 inches of the material was $960.
Ooh.
And I have to tell them that Swiss machines have a remnant, which is probably going to be about 5 inches. So we have like 7 inches of material per $1,000 to work with.
Ugh.
Maybe that's okay. I don't know. So I gotta think through that one a little bit.
That's tough.
See what he says.
Yeah. Makes me squirm a little bit just thinking about it.
It could be interesting. Like, I'm not opposed to it. And I said it's not the machining that bothers me. It's like just trying not to lose money on the deal.
Right.
So if they want to front the material and like just kind of a good faith, like I'll try to recover most of the chips. All right.
Yeah. Just like, can't make any scrap. It's like, it's everything's got to be dialed.
I got to give it back to them if I do.
Right. Yeah, exactly. Oh boy. Well, Dan, I really appreciate you coming back on. It was great to get to check in and talk shop again and all that fun
thanks
stuff.
for having me.
Where can people find you? I didn't start the episode like that, but where are you on Instagram and all that?
Yeah, so my Instagram is Danny Rudolph. I'm sort of on there less than I had been in the past, but usually I'm running around in the shop. But yeah, follow me, and I'm in the stories a lot of the time.
You do cool stuff. It's like,
thank you.
Your business is enough removed from mine that I'm constantly amazed at the things you're doing. It's like way out of my realm. So it's really cool.
Yeah, that's like me when I look at Josh's or Adam's page, or it's fun to have those guys that do stuff you just don't see on a daily basis.
Totally. And then no new Patreon thank yous this week, but thanks for everyone who does back. It makes episodes like this possible. And again, thanks Dan, and thanks everyone. We'll be back next week.
All right. Hey, thanks.